Okay, good afternoon, everybody. It's 1 o'clock, and so here we are, all set up, ready for some exam review. Now, depending on the screen that I'm looking at, it says that there are, I don't know, anywhere between 0 to 4 people watching right now, so I don't know who's here. Um, oh, there's Jack. And so if you are here, just comment so I know who is watching, and we can start answering some questions. Page 51, 11B. Okay. I'm just going to get my textbook open. I thought I had it open, but it looks like I don't. Why do I feel like I've done this question before? I don't know why. Something about it is. And I haven't actually pulled up the question yet, but something um, about that question, page number and question number sounds familiar. Is it the pens one, I wonder? Oh, it is. Yep, that's why it sounded familiar. Alrighty. Let's screenshot that. Pop it in here. So this is from review set 1B. It is a quadratics problem, specifically an optimization problem. So I'll just write up here, quadratics, optimization. Or a few other people who popped in there for a second, so if you are here, please just make sure you say hi so I know who's checked in. And yeah. Okay, so Donald's asking for just 11B, find the dimensions of each pen so that it has the maximum possible area. Okay, so in the context of a problem like this, where you're trying to optimize something and figure out a maximum or a minimum, oh, good question, Jack. So Jack's asking, how do I know it's a quadratic? Um, so basically, the only time I'm going to ask you to do optimization problems at this point in time, it'll usually be something that's based off of a quadratic, because the only other way you can find a max or a min of something is with your calculator. So if you look here in this question, it says find the dimensions of each pen so that it has the maximum possible area. And the only way we've established how to find maximums without a calculator is by finding the vertex. So a maximum would be a vertex, or a minimum would be a vertex of a quadratic. We haven't really talked about algebraic ways to do that for anything else. If I ever asked you for any other maximums, it would just be a matter of, okay, let's sketch this on the calculator and find the maximums, which you can do by accessing the calculate menu under second function and clicking, no, the button doesn't say calc, the button says trace, but it says calc above it. And so if you do second function and click on the trace button, that will get you into your graph analysis menu, which allows you to find a max and a min. And so we can actually look at how you would do it both ways here. We're going to get the same answer. It's fine either way. But from part A, what we already have established is that the area can be given by this equation, x times 600 minus 8x over 9. And if I was to multiply that out and simplify it a bit, I get 600 over 9x minus 8 over 9x squared, which is a quadratic. right? It has an x squared term in it, and then that makes it a quadratic equation or quadratic function, and so that's what I'm working with here. So knowing that that's a quadratic, I know that the maximum, if there is one, is at the vertex. And so we know that to find the x value of the vertex, it's on the axis of symmetry. So I have that equation in my formula booklet, x equals negative b over 2a. That is how I find the equation of my axis of symmetry, but also how I find the x value of my vertex. So with this one, the b and a values aren't great. Sadly, in a lot of real life application kind of situations, the numbers don't work out to be the most elegant. They're not terrible here, but I think most of you, because there's fractions, would be a little dissatisfied with the way this works out. But it actually isn't too bad. It's a negative on top and bottom, so the final result's going to be positive. So I have 600 over 9 divided by 16 over 9. I just divided out those negatives. And because they're both over 9, if I were to multiply on top and bottom here by 9 as well, I will get 600 over 16. And then I can reduce that a little bit further, because if I think about dividing top and bottom by 16 and whether it goes in evenly or anything like that, even if you were to just whittle away at it and say, oh, okay, I know 2 goes into 16 and 600, so I get 308, and then hopefully you realize to keep going, 150 and 4, and then 75 and 2, and then it doesn't go any further than that. And I think if you had your calculator, I'm just pulling up my calculator now on my phone. Pretty sure if you were to do 600 divided by 16 and got it as a decimal, there is a command under the fractions button, or sorry, under the math button. If you were to press math and then there's a little thing that says arrow to a fraction, it would convert it back to that fraction for you. So you could get 75 over 2 or leave it as 37.5. It doesn't really matter. But if you thought the equation to find the maximum was too complicated, or maybe it wasn't even quadratic, maybe it was something a little bit more weird. Like I noticed Michael is now in the chat, so let's say it was a quartic, which is one of Michael's favorite things, or at least it was earlier in the year. I seem to recall he liked them because they look like an M if you have them set up the right way. I guess I should put a negative on that one just to make it look appropriate. Now I'm going to pull up GeoGebra here and hope that my focus for the stream is still on the right app. Let's get GeoGebra open. It will probably take forever because for some reason my computer is running very slow today. Come on. Well, GeoGebra doesn't want to open. That's unfortunate. Something tells me it's going to pop open in like a few minutes. But as I said, if you were to graph the quadratic, so if you got out your calculator and typed in 600 divided by 9 x minus 8 over 9 x squared, and then graph it, you would get a quadratic that opens downward. And then you'd just be able to use that trace command to find the maximum point. And that would be fairly quick to do, I would think. Wouldn't take you too long to type in any sort of function you need to find a maximum of. And so, oh, here we go. Haha. All right, now we're in business. So let's try with that quartic that I put up there. So this isn't something that you would be able to do algebraically. But if you did get a problem like this, you could very easily type in the function to get a graph. I think this is what it was. And so if I look at this graph here, the way you would actually do it on your calculator is a little bit different than the way I'm going to do it here in GeoGebra. But I can kind of see once I've graphed it where the maximum is. And so for you guys on your TIs, you would go second function, the trace button, and then it allows you to do all sorts of things. Find x-intercepts, find maximums, find minimums, find points of intersection. And so you would be able to do that fairly easily. And in fact, when you're writing the paper 2 and you have your calculator at hand, I really, really hope that you'll actually make use of it when you're faced with a question that, maybe could be done algebraically, but when you look at it, you're like, oh gosh, why would I bother? So if you were to type in second function, trace, select maximum, and then it has you do the left and right bounds, GeoGebra won't have me. Well, actually, GeoGebra does require that I do that, but it doesn't let me drag it. You guys will have to move the cursor, and it makes a vertical line. I, on the other hand, just get to type in a range and say, find the maximum in between there. Oh, and it got angry at me. Oh, right. Not as a range, lower value, upper value. And there we go. And so it plotted the point, and so now I've found the maximum of that function. So you can do it analytically with a calculator if it's a paper 2 question. If it is a paper 1 question, then, oh boy, it's like GeoGebra and OneNote can't coexist apparently on this stream. So goodbye, GeoGebra. You are killing my computer right now. Wow, I'm having some killer technical difficulties here where it's like nothing I click is actually responding. Aha, okay, we're back to OneNote. All right, so again, on these types of questions, like the one Donald asked about, it's either a matter of just using negative b over 2a to find the vertex. That's how you can get the maximum. Or alternatively, it could be about using your calculator and setting it up that way. Okay. So let's move on to Donald's question. He asked for me to do the practice paper 2 question 5. So practice paper 2 being last year's exam. Let me just go and find that. Last year's final 2017. And sorry, paper 2, question 5. All right, paper 2, question 5. Oh, the trig one. Yep. Okay, let's copy that one over. I'm copying it over from the solutions, so that's why there's a little bit of writing on it. All right. So a runner is jogging around a level circular path with a statue at its center. The diameter of the circular path is 120 meters. The runner starts on the path due east of the statue, and she takes 80 seconds to return to her starting position. Years of training and discipline allow the runner to jog at a constant speed. The runner's distance north or south from the statue is given by the function a cos b of x minus c plus d, where t is measured in seconds. Okay, determine the values of a, b, c, and d. A picture is always very helpful to guide here. So let's say that this is the statue, and then we have the path that the runner is taking. It's a perfectly circular path around, and we are told that the diameter of that path is 120 meters. So that means from here over to here is 120 meters. I should take off my shape tool because it's messing things up. So it's 120 meters from one side of the circle to the other. That means the radius of the circle must be 60 meters. So this is helpful because what this allows us to establish is essentially how far north or south of the statue the runner is able to reach as she runs around. So if this is a bird's eye view, and then we label this north, east, south, and west, we're told that she starts here, due east of the statue, and then she starts running. Now, it doesn't actually specify technically which direction she starts running, so there were actually multiple acceptable answers for this function, which was fine either way. And so, anyway, we know that the furthest north and south that she can get is 60 meters, and so that actually gives us one of the 4 parameters for this. It's going to give us the amplitude, because if we consider that sort of east-west line that she's on as being her baseline, it means she can only ever go 60 meters north of the baseline or 60 meters south. And so that tells me that A would be 60 meters. It also allows me to basically say that D is 0 meters, because if I say that the east-west line is her baseline and she just keeps going north and south and north and south as she runs around, then that means that that east-west line is the baseline, so I don't have to actually account for any shift there. So I've already figured out both vertical parameters, and now I can move on to the horizontal ones. We are given another piece of information here. What did I give you guys? She takes 80 seconds to return to her starting position. So that means that one cycle, one loop around this circle takes her 80 seconds. And so that is the period of this function. 80 seconds before she's in the exact same spot where she began a cycle. Now we know that the period of a sine or cosine function is 2 pi over the b value of the function. So we'll put in 80 here, and we can solve for b. b is equal to 2 pi over 80, which is equal to pi over 40. So now I have 3 of the parameters that I'm looking for. I have the b value, I have the a value, I have the d value. And so we really just have to look for C now. So the question becomes, how do you account for that? And C is always usually the trickiest one for people, because some people will look at this and they'll say, all right, so I know A is 60, and I know, oops, I should put cosine in there. I know that B is now pi over 40, so that's great. And then they're saying, okay, x minus C, not sure what that is yet, plus 0. And the function kind of looks like this so far. Now, if you were to set C equal to 0, that would mean the function is going to look like this through one 80-second cycle. The problem with the curve looking like this is that here at the maximum means that she's directly north of the statue. And here at the minimum, it means she is directly south of the statue. But that's not actually where she starts. She starts east of the statue. She starts east of the statue, and then well, the way I'm setting up the function, she starts heading north. You could have had it so that she's heading south too. You still would have had an acceptable answer, and that's fine. But we're looking at her heading north here, and so I want her to be starting here at the baseline and heading this way. And what that means is I have to figure out how much the curve gets shifted to make that line up properly. Or another way of thinking about it is how many seconds is she running before she hits the default starting point of a cosine. So my current equation, if C was 0, would have her starting here and then going through this loop in 80 seconds. What I'm wondering is, given that I know she's running from here to here, how much time does she spend running that section before she gets into the cycle properly? And if you think about it, it takes her 80 seconds to go all the way around. That means it takes her 20 seconds to go a quarter of the way around. And so if I just take that 80 seconds and divide it by 4, I get 20 seconds. And that's how much time it takes her to get to that northernmost starting point. And so what's actually happening here is the cosine curve has to be shifted right by 20 seconds, because it takes 20 seconds before she hits that maximum, which is the start of a cosine cycle. And so that tells me that C has to be equal to 20. And then when I say my equation is d of t is equal to 60 cosine pi over 40 x minus 20 plus 0. So what that's done is it's shifted the cosine curve to the right by 20 seconds. So it means that this point doesn't show up until 20 seconds into the run, which is actually accurate based on the situation we've described. And so that's what we want to do in this kind of situation, is make sure that it lines up appropriately, that we actually have the shifts that properly reflect the situation. So a cosine curve would normally start at its maximum. That would mean she'd have to start north of the statue. She doesn't get there until 20 seconds later, so we have to shift it right by 20 seconds, give her the time to kind of run to that point, and then she gets north of the statue, and then the cycle can continue as expected. So that's all part A. Part B, the runner receives an urgent phone call after running for 142 seconds, causing them to stop in their tracks. Determine the north-south distance from the statue at this time. So basically what I'm asking you is, if you've got that west to east line that they keep kind of running around, how far north of it or south of it are they when they stop for the phone call? And so the way to figure that out is basically just plug 142 into this function. So I have 60 cosine of pi over 40 times 142 minus 20, so 122. And I'd have to evaluate that. Now, this was on a paper too, so you have to assume I'm not necessarily giving you nice numbers on a paper two. You have your calculator, so there's no reason why you couldn't use it. So if I am looking at my calculator, I just need to check that mine is in radians. And it is good. Okay, so I'm going to do 60 times cosine 122 times pi divided by 40. And what does that get me? I don't know why I was rewriting this again. That was unnecessary. The number I get is minus 59.3. So what this is telling me is actually that it is 59.3 meters south of the statue. Right? Because I'm 59.3 meters below my baseline, which means towards the south. And so that's why that one was only worth, 3 marks? Because I wanted to see that you could, first of all, know how to use the model. Second of all, evaluate properly. But then third, I wanted to see that you would properly interpret the results. Yeah, and that's paper 2, question 5 in a nutshell. So I don't know if there are any other requests. So far, I have seen of the 5 people who are here, there have been, 3 of you to check in? I just realized that Michael confirmed that the quartic is still one of his favorite functions. That's good. All right, into the chat. Any other questions or requests? And one on... my first comments not show up for people? Practice paper 2, question 1. All right, practice paper 2, question 1. Okay, so Jack is requesting question 1 on practice paper 2. And James is here apparently. And Michael, question 6 on paper 1. All right. Let's see what we can do here. Oh, am I doing that thing where I keep writing bigger and bigger? I need to stop that. Come on, don't get all distorted. There we go. Okay, so that's the one that Jack asked about. Michael asked for paper 1, question 6. Paper 1, question 6, which, oh yeah, that's a good question. I do like that one. Good choice, Michael. Oh, what? Didn't screenshot properly. Apparently my computer doesn't want me to do that one, Michael. There we go. It is still screenshotting so small. Ridiculous. Okay, let's see. We're going to do Jack's question first. A survey of high school graduates was conducted to investigate the number of awards they had received in their final 2 years of school. The results are collected below. So number of awards apparently range from 0 up to 5. And then it says number of students. And one of the values is missing. If the mean of the data set is 2.6, determine the value of P. All right, so this one was about doing measures of center, specifically mean, using grouped data. So these are our actual X values, whereas these guys here are our frequencies. And so this formula is actually given in your formula booklet. If you want to find the mean, you do the sum of the frequencies times the data values divided by the sum of the frequencies. And so that is provided to you. You may have to do that by hand at some point. It's perfectly conceivable. I mean, not always a guarantee, but obviously I have done it before because this is last year's exam. So what this looks like then is basically you're taking all of the data values, so the number of awards, and you're multiplying them by the corresponding frequencies, and then you're just adding those up. So I would have 0 times 3 plus 1 times 7 plus 2 times P plus 3 times 14 plus 4 times 7 plus 5 times 4. And I will divide that by the sum of all the frequencies. So this is why you can see there's already some writing on these questions. Again, I copied these over from the solutions that I posted to our class OneNote. And so I just added up everything except for P. So the 3 and 7 on the top is 10, and then the ones on the bottom add up to 25, which means that in total they add up to 35. So the total frequency is 35 plus P. Now the reason why this is useful is because this is giving me an equation in terms of P for the mean of the data. So if I simplify on the top, 0 times 3 is 0. I'm going to end up with 7 plus 2P plus 3 times 14 is 42, and 4 times 7 is 28, and 5 times 4 is 20. And if I tidy that up a bit, I get, what do I have? 70, 90, 97 plus 2P over 35 plus P. And that's the mean. But I'm also told what the mean is. I know that it's 2.6. So this actually gives me enough information that I now just have an equation in terms of one variable. Everything's in terms of P. If I multiply 35 plus p over to the other side. Let's see, 2.6 times 35 is 91. So I'm going to get rid of the fraction here, multiply the denominator over to the other side, and I get 91 plus 2.6p is equal to 97 plus 2p, which is a nice linear equation, something you guys could have done easily in grade 9. So if I move stuff around, I get 0.6p is equal to 6, which means that if I were to divide both sides by 0.6, I'm going to get 10. So, well, here, okay, maybe that wasn't apparent right away. 6 divided by 0.6. So if I divide top and bottom by 6, I get 1 over 0.1. So that's 1 divided by 1 over 10. When you divide by a fraction, you multiply by the reciprocal, so 10, right? And that's how we get our answer. This was also on a paper too, so I guess more realistically, I'm sure many of you would just punch that into your calculator and it would have given you 10. I always prefer to do as much by hand as possible, even though that's not what the IB expects. It's handy to have good number sense. Now that I have all the data, so I know that P is 10, so I have a complete data set, when it asks me to determine the standard deviation, the reason why that's only 2 application marks is because I am fully expecting you to just do that in your calculator. So you will type in your full data set. Your values 0 through 5 will go into like your L1, and all of your frequencies will go into your L2. And then what you're going to do is click on Stat, go over to the Calc tab, and do one variable statistics. And you need to make sure you set up the appropriate lists. So L1 for list, L2 for frequency list, and then calculate. And what that gives you then as standard deviation, which I briefly forgot, that's what we were looking for. I get 1.34. So this we enter X into L1, frequency into L2, and then we're doing the one variable statistics. And I know I keep going over instructions on where to find those, but it's really important that you guys know where to find them. There won't be any similar prompts on the test or on the exam. Whatever it is you guys are writing tomorrow. Test, exam, it's all the same thing. I just noticed James is asking about paper 2, question 5. Paper 2, question 5 has already been done in the stream. I will add question 6. There we go. And on to Michael's question 6, which was from paper 1. Consider the functions f of x is equal to 6 to the x minus 1 over 2. G of x is equal to 2x squared minus x. Yes. Okay, I remember this question because I had to very carefully craft it to get it to work out exactly the way I liked it. And Donald's requested paper 2, question 7. All right, hang on. I'm just going to make a little note of these so I don't forget them, because as the chat keeps scrolling by, I'm going to have to go back and look through them. Okay, so 6a, pretty straightforward. Find the inverse of f. So this is something for sure everyone should know how to do. I have very heavily or consistently suggested that because logarithms and exponentials go hand in hand as inverses of each other, but they're actually like interesting inverses, I do tend to focus things in that kind of direction. I mean, I do inverses of other functions too, but if you think about it, we don't do inverses for trig in SL math, and inverses for quadratics aren't actually functions. And there are ways to make functions out of them, but that's not part of SL either. Inverses of lines are just lines. That's super boring. Inverses of rational functions are interesting, and there's a little bit of algebraic stuff there to be done. But here, I mean, I really like the idea of exponentials and logs because they go so closely hand in hand. And in case it wasn't clear then what we're actually building up to, the inverse of f is going to be a logarithm. So here's my exponential. And so I want to inverse this, so I'm going to swap where the x's and y's are. And then let's rewrite this. So this would be the log base 6 of x is equal to y minus 1 over 2. And so here I'm just using that rule from your formula booklet that says if I have something written as a to the x equals b, I can rewrite it as log base a of, oh, almost wrote it incorrectly there. Log base a of b equals x. And so that's in your formula booklet, perfectly accessible for everyone to be able to reference that, so really important that you do so. Once you've actually done that whole piece and rewritten it as a logarithm, it should be really easy to isolate y again. So multiply both sides by 2 to get this, and then nope, not subtract. Sorry, I'm already subtracting 1, so that means I add 1 to both sides, and I end up with that, which is the inverse of f. And I ask you to write down the domain of the inverse. And there is a reason for that. Some people are probably looking at that and they're like, oh, one communication mark. That seems so ridiculous. But no, when you look at that inverse, it's a logarithm. We've talked about how logarithms aren't defined if your x value is, if it's not, sorry, not if your x value meets a certain requirement. If what is in the logarithm, the argument of the logarithm, here it just happens to be x, but in general, it's whatever is in the logarithm has to be greater than 0. We can't evaluate a logarithm with the argument being 0. We can't evaluate a logarithm with the argument being negative. We've talked about why. I'm not going to reiterate that here because I think it's just really important to have that as a fundamental understanding. And if you want to parse out the why and everything of it, you'll have to do that another time. But here, the idea is I know that what goes into that logarithm has to be positive. So what that tells me is my domain has to be all x values greater than 0. That's the only way I can make sure the stuff going into that logarithm is not negative or is not 0. And so that's going to be helpful in a minute because in part C, I'm asked to solve for x if the inverse of f composed with g is equal to 3. So anytime you get a question like this, your first instinct should be, let's just set up that equation. So f inverse is 2 log base 6 of x plus 1. Now, I'm not going to actually put the x in because I know I'm doing a composition. And so what's actually going in that logarithm is the function g, which is 2x squared minus x. And so there is my function. That's f inverse with g inside of it being equal to 3. And I'm going to have to solve for x. So whenever you're solving a logarithmic equation like this, you want to make sure you get it so that it's just the logarithm is equal to a number, because then it allows you to use this rule again and rewrite the whole thing. So I'm going to move that 1 over to the other side by subtracting both sides. And I will get this. And then if I divide both sides by 2, I get log base 6 of 2x squared minus x is equal to 1. So if I rewrite this now as an exponential, because again, this is log base a of b equals x, so I could rewrite it as a to the x equals b, this is going to become 2x squared minus x equals 6 to the 1. And so I've rewritten it there. And this is now just a quadratic. 2x squared minus x minus 6 equals 0. So anytime you see a quadratic that's equal to 0, you should know that you should be factoring and then solving. So when I go to factor this, and I'll do this just for some people who still need the kind of guidance to see what I'm looking for. I need two numbers that multiply to be negative 12 and add to be negative 1. Those numbers in question would be minus 4x plus 3x. Those are the ones I'm looking for. So I split up that minus x term in the middle into minus 4x and then plus 3x. And then I have to common factor out of the first two, 2x, which leaves behind an x minus 2, and common factor out of the last two. And I can factor out a 3, which leaves behind an x minus 2. So this, when it's factored, works out to be x minus 2 times 2x plus 3. And that's all equal to 0. So what this tells me is that x is equal to 2 and x is equal to minus 3 over 2. And if you left it like that, you would have only earned, what was this out of, 6 marks? You would have only earned 5 of those 6 marks. The reason for that is because one of those answers is inadmissible. And I tried to, when I constructed this question for last year's grade 11s, I tried to kind of prime them with that by having them find that domain early on, right? They'd already established that x had to be greater than 0. So hopefully at this point they were looking at it and they said, oh, okay, x equals 2. Yes, that one is fine. Oh, x equals negative 3 over 2. That one's outside my domain, so let's get rid of it. And so that's how you would proceed through this kind of question. It is really important to have those realizations, and so, you know, that is a key part of what I'm looking to see here. Just looking in the chat to see who's shown up. So Ian, I guess, has popped in and out. I feel like there are some people who have not stayed for the full time because we seem to be hovering around 6 people, and yet I feel like I've seen more than 6 names. Jack, Donald, Michael, James, Ian. Oh, wait, maybe Hannah? Okay, yeah, maybe that is 6. All right. Okay, let's look at those other requests. So, question 6, question 7 were the ones requested by James and Donald. And question 6, I think, was an exponential decay. Yep. Oh my gosh. Every time I screenshot, I have the desktop audio turned off so you guys can't hear it, but man, it is just blaring in my ears every time I screenshot. Okay. Question 6 and question 7. Oh yeah, question 7's a good one. Oh. I mean, I guess I felt at some point like all of them were really good ones, considering I made these ones. Okay, let's have a look-see. Okay. Whoa. Okay, I'm having the worst buggy experience with the Surface today. All right. The air temperature T in degrees Celsius around a light bulb is given by the equation T of x is equal to A plus B times 2 to the negative x over K, where x is the distance in millimeters from the surface of the light bulb. The background temperature in the room is a constant 25 degrees, and the temperature of the surface of the light bulb is 125 degrees. So this being an application question, there's obviously some information here that I'm giving to you without like directly handing it to you. And so what I've said here is that the background temperature in the room is a constant 25 degrees, and the temperature on the surface is 125. So that means if x is representing the distance from the surface of the light bulb, when x is 0, the temperature is 125. So let's take a look at what that actually provides me. So when the distance is 0, I have A plus B times 2 to the 0. And I know that this would be equal to 125. So this is actually just A plus B equals 125. That's kind of helpful because it gives me a single equation. Now, the tricky interpretation piece here, I suppose, is recognizing how the background temperature in the room is relevant. So the idea is if that bulb was turned off for, I don't know, years, and it just sat there, it would reach a temperature that was the temperature of the room, right? And so it wouldn't be any hotter. It wouldn't cool anymore because that wouldn't make sense. It can't get colder than the space that it's in. And so what that means is that it's going to level off to a temperature of 25 degrees. So what that actually means from an exponential perspective, because this is obviously, or hopefully it's obvious, that this is an exponential decay situation. The temperature is really hot when the bulb is on, and it cools down as time goes on. And so if you recognize that, then conceivably what you recognize is that the horizontal asymptote is 25 degrees Celsius. That's as cold as it can get, or cool. Well, I don't know if I'd even describe that as cool, but that's as low as the temperature of the bulb will get over time. So if I know A is 25, then that means that B must be 100. And so now I can actually fill in two of the parameters right out of the gate. For part A, I know A is 25, B is 100. And so my function now looks like this. 25 plus 100 times 2 to the negative x over k. And so in A, it says if the air temperature 3 millimeters from the surface of the light bulb is 75 degrees, then we're going to find the values of A, B, and K. So we already found A and B. To find K, I just need to set up another equation where I plug in for X the value 3, and the corresponding temperature is 75. So I'm plugging 3 in for X, times 2 to the minus 3 over K. And then I just have to tidy this up a bit. So I'll move the 25 over to the other side, and what I get here is 50 is equal to 100 times 2 to the negative 3 over k. If I divide both sides by 100, I actually get 1/2 is equal to 2 to the negative 3 over k. And so this is now an exponential equation I can solve. This is 2 to the minus 1 equals 2 to the minus 3 over k. The bases are equal, so the exponents are equal. And if I solve for k here, I get k is equal to 3. So now I have all of those parameters all laid out and ready to go. So what my equation looks like, which I suspect I will need for B, yep, determine the air temperature 2 centimeters. So my function now looks like this. 25 plus 100 times 2 to the negative x over 3. That's it. That's the model. And so in part B, where it asks me what is the air temperature 2 centimeters from the surface of the bulb, so that should be a matter of plugging in not 2, but 20 into this function. I shouldn't be using an x for a time. Sorry about that. So we're going to plug that in. I'm going to evaluate that on my calculator. Because again, this was a paper 2, so why not? It's easier, I think, than trying to do it by hand. So to the negative 20 over 3 is my exponent on 2. And I get, as an answer there, approximately 26 degrees. So there you go. That's your answer for B. I think in the solutions that I posted online, because I had to do up new solutions, I couldn't find my old ones digitally while I was on trip. I think I misread the question because I was reading it on the bus. And I think I read it as 2 millimeters. So I'm pretty sure I gave an answer that would be closer to 100, like between 175, because I misread that. So I guess it's important to note the corrected version is here. I'll go back and fix that at some point once we're done the stream. And finally, what does it ask? See, sketch a graph of air temperature against distance from the surface of the bulb. So this is actually very quick to do. Remember, it is just a sketch, so I need to have some key values. So we basically know that we've got a horizontal asymptote at T equals 25. We know that the starting temperature of the bulb is 125, right? The yeah, the maximum temperature. I don't know how we want to refer to that. It's just the temperature on the surface of the bulb. And so this is at 125 degrees, and then basically it's decaying from there. You could plot on some other points because technically you do have some more information, but that's a sufficient sketch. Um, okay, so that's it for question 6. On to question 7, where Donald is asking, how do you turn a TI Nspire into radians? So I don't have an Nspire in front of me. I actually don't have an Nspire at home even, and so I wish I could. I wish I could actually show it. So the tricky thing is, for the TI Nspire, there are different angle settings depending on which um, application, I guess, of the TI Nspire you're in. And so if you're on the calculate screen and you do menu and go into your settings, there's an option there. But then somewhere in your master settings, there's an option for which one to graph with as well. And so you just need to make sure that you find the appropriate setting that you want to change. Or at the very least, know how to change them all. So let me see if I can find some screenshots. Um, on TI Nspire. Now, even if I did have a calculator here, I don't think I'd be able to show it very clearly. I really got to get one of those TI Smart View programs, the ones that let you put the actual stuff on your screen or on a TV or something. Oh, I found the perfect picture actually to highlight it. All right, so for Donald and for everybody else, come on. So there's a. Why is it way over there? Come on, OneNote. Get your act together. So here is a screenshot. It's a little bit blurry. I just pulled a quick one off of Google image search. But the problem is it was such bad quality to begin with, and now I'm trying to make it much bigger than it was. But you have different settings on a TI Nspire. So under your regular settings, there's the angle prompt right here, which I'm pretty sure changes it for when you're in just your calculator. So you go to your calculator, you do sine of whatever pi over 6, and if it's not in radians, it's going to give you a different answer than what you would expect for sine of pi over 6. So you wouldn't get 1/2, basically. You would get something else. Um, and then if you want to actually graph properly in radians, then you have to actually be usually in a graph window. And then if you go to settings there, it will give you the option for geometry, which I can't imagine anyone who is using a TI Nspire is using it for geometry. You'd be able to do it there, and the graphing angle. And so Donald says he's found it, but I think there are a few other people who use TI Nspires. I know Emily had one. Jack, I think, has one. Max. So anyone who is looking to do that with a TI Nspire, that would be how you do it. It really is important that you know where those settings are, just because your calculator is going to get reset at times, or you're going to change the settings for one class and then forget to change them back for another. You really just need to be comfortable going back to your calculator and tweaking those things, because it's a huge, huge risk if you don't. And the people who are in the exam with you won't know. because you won't have math teachers proctoring your exam tomorrow. I don't know who is. I have the schedule. I can check, but it's irrelevant because the point is they won't be math people. And so you need to make sure that you know. To Haya's question, you will only have to change from degrees to radians or vice versa. It depends on what type of problem you're doing. So if you get a trig problem that looks like this one, number 7, then it's in radians. So I would just set my calculator to radians and get to work. If I could have given you the same question in degrees, in which case I would have expected you to work through it with your calculator set to degrees. So you really have to make sure that you're adjusting the settings on your calculator based on the circumstances you find yourself in. So I just take a cue from the question, because basically if things are in degrees, work in degrees. If they're in radians, work in radians. I think I set up the exam in such a way that you won't have to be changing your settings on your calculator repeatedly, because there's only a little bit of trig, I think, on paper 2. And we've already talked about that, because I said the first question was a trig question in degrees, and I want to make sure that, given that you'll have reset your calculator, and then you're an hour in before you pick it up, I wanted to make sure that everyone remembered to change it back. Otherwise, you'll be kicking yourself for it. But this one, which was requested by Donald, is not in degrees. This one's in radians. So you would switch your calculator into radians. Now, you're asked for the measure of BOA, which is this angle right here. And so what we want to do is use sine law. I know I have this angle written here. That was just because I copied again from the solutions. But you want to use sine law because you have the angle you're solving for is across from a given side, and the angle you're given is across from another given side. So we've got 5.5 across from 3 pi over 20, and 9 is across from the angle I'm looking for. So if I was to set this up, I would say sine of angle BOA over 9 is equal to sine of 3 pi over 20 divided by 5.5. So if I go to solve here, we are going to have this stuff. James asks, why can't I convert them to degrees and enter them in my calculator? James, I don't know why you're talking like this. Also, for the record, when you type M, it should be the apostrophe before, because that's where you've abbreviated the word. You took off the TH of them to make And I don't know why you're speaking like some country bumpkin. Welcome to Mr. Grant's exam review / grammar review. So when I calculate 9 times sine of 3 pi over 20 divided by 5.5, I get 0.742-ish. It doesn't really matter because I'm going to do sine inverse on that immediately in my calculator to get the angle that I want. And that gives me 0.837. So that means that this angle that I'm looking for is 0.837 radians, approximately. And so to find that missing angle, ABO, which I'm going to need in a second, I'm going to have to subtract that from pi, which is the equivalent of 180. So pi minus 3 pi over 20 and minus 0.837 will give me the angle AOB. And so I think that's what I did before, and that's how I got 0.366. And so again, that's just a quick typing it into your calculator, 0.366. Some of you, I've noticed, seem to always think that when pi is in the mix, that somehow your calculator has to be in radians to do any calculation there. But pi minus 3 pi over 20 minus 0.837, that can be done whether your calculator's in degrees or radians. The only reason it needs to be in degrees or radians is if you're using the trig ratios sine, cos, or tan. Because what it's doing, and we talked about this in class, but what it's doing is you're putting in an angle for the corresponding trig ratio, and then it's basically looking up the corresponding ratio of sides. So you do sine of pi over 7, and it needs to know it's in radians because it basically needs to know which book to go to look up the ratio. So almost picture it as if there's a book about trig written in degrees and a book about trig written in radians. And if your calculator doesn't know which book it's supposed to be looking in, then it's going to give you the wrong number, right? If it assumes that that pi over 7 is in degrees, it's a really small number of degrees, but you're going to get the corresponding value that would match for that angle in degrees. And that's why you have to make sure your calculator is in the right setting. But if you are not using sine, cos, or tan, it does not actually matter whether it's in radians or not. Anyway, now that I've figured out angle AOB, I could figure out the length of OA. This one I would use cosine law for. OA squared will be equal to 9 squared plus 5.5 squared minus 2 times 9 times 5.5 cosine of 0.366. Did I? Oh, I wrote down the wrong angle. Thank you, Michael, for catching that. It's not AOB. It is ABO. And this is where the 30-second delay or whatever it is really inconvenient. But thank you, Michael, for catching that. And thank you, Haya, for supporting Michael and catching it as well. The things that we aren't able to do as smoothly when it's not in person. Anyway, so I'm typing everything for cosine law into my calculator now because I want to figure out the length of OA. My phone calculator is going super slow, which is just awesome. And I get the length of OA, after I crunch the numbers here, is approximately 5.22. And this was all measured in centimeters, meters. Okay. So we've measured it all in meters. We've got our answer. We are all set. So that's the answer for B. And we need to look at C. If COA is half the size of BOA, determine the area of the minor sector OCA. Okay. So we've already figured out angle BOA. We're being told that this angle is half the size. Now, before we go too much further, I think we've made a mistake. Did we make a mistake? I wonder. For the record, I know that we did. I just have to wait an awkward amount of time to see if anyone will comment on it in the chat. So, anyway, because I'm realizing that there's a certain degree of futility in waiting. Oh, thank you, Donald. Wait, ABO? Yes, ABO isn't right. But more importantly, it's not right based on the numbers we had written. And the reason it's actually not right is because the answer we got for this one wasn't right. And the reason is because if I look at this, when I solved for this angle here, this was actually an ambiguous case scenario. The angle I solve for is actually one that would be over here in this space. That's the acute angle that could be made with those side lengths and those angles. And so had you gone through and maybe found the correct ABO, or sorry, a valid ABO based on this incorrect angle, you would have received follow-through marks. You just wouldn't receive all the marks on part A. But technically, the actual value of BOA that I'm looking for is going to be supplementary to the one that my calculator gives me. I'd have to do pi minus 0.837, which gives me 2.304. And so what that does is then down here, this angle should be 2.304, which does get me 0.366 as an answer. Now, I just want to check something because for some reason, oh yeah, I had a calculator error though on this calculation for OA because I was thinking to myself, I don't remember it being isosceles. It's because my technology is all glitching out on me and everything's going super slow. Which on my computer I understand because I am writing and streaming and doing all that at the same time. But on my calculator, it does not make sense because that's a separate thing. So the error that I made is apparently when I typed it into my calculator, I typed in 5 for this instead of 5.5. So this answer actually is not 5.2, but it's close. I think it's supposed to be smaller. Let's have a look. 4.3. There we go. I knew something wasn't shaping up right there. So 4.34, I guess, if we round it properly to 3 sig figs. And so now that's all been tidied up. If you're wondering where you need to consider ambiguous case, it's high is saying 18.80. What does high mean? Oh, that's OA squared. So if you square root that number, high, you'll get 4.34 as the missing side length. Anyway, back to the topic of this being related to ambiguous case. So the tricky thing is this one's not. It's not technically ambiguous. The diagram is given to you, but you do have to remember to find the corresponding obtuse angle, knowing that the calculator is giving you the acute angle that satisfies those conditions, which is something that we didn't do initially. And it only dawned on me when it said that COA is half the size of BOA, and I was thinking, gosh, these angles are really small, but they're definitely bigger than 180. And then I realized that they weren't. And that's how I got it. Okay, so now that we've tidied that up, we're going to do part C. So if COA is half the size of BOA, so COA then is equal to 2.304 divided by 2. Which is 1.152. And it says determine the area of the minor sector OCA. So OCA, if I was to just redraw it here for us, the sector that looks like this, we now know that this angle in here is 1.152. This was O, A, and C was down here. The length OA is 4.34, but we also know then that this side is 4.34 because it's a sector, so that means that OA and OC are the same length, right? Because it's a chunk of a circle. Those are both the radius of the circle. And so if I wanted to figure out the area of a sector, I would do 1/2 times the angle of the sector times the radius squared. So 1/2 times 1.152 times 4.34 squared. And what I get from that is 10.85 meters squared. And that would be the area of our sector. So this question was a big geometric trig question. I tied in cosine law, sine law, and arc length sector area stuff. Not uncommon if I make it into a big question for those ideas to come together. I think this exam, I didn't really have any bearings on it, did I? And so that's sort of the one thing that was missing from here. Now, I wouldn't have done a question like this with bearings because that's too much. If I was to put bearings into something like this, I would probably split it out and do a bearings question with sine law, cosine law, and then do an arc length sector area thing as a separate piece, because I worry that when I jam too much into a single question, if you trip up over one of those things, it's going to prevent you from doing so many of those things, and I want to make sure that that doesn't happen. I want there to be an easy enough gateway into the question, and that you're not just losing because there was too much there. All right, scrolling back through the chat and just seeing what people want done. Ian's asking for 6A number 10. So 6A, this is review set 6A, I'm assuming. See, no one is telling me my page numbers, though. My comments at the start of everything said I need page numbers. I'm dealing with a digital textbook. I can't flip very easily. So 6A. Oh, darn, I lost Ian's question. 6A number 10. Oh, yeah, the ball bouncing. I was looking at some other textbooks recently, and I cannot believe how popular this question is. A question about a ball bouncing and what's the total height that it's gone or something like that. And so this question, for the record, will actually satisfy Jack's request because this is a geometric series question. And then I saw Coco asked a question, review set 10C number 5. I will get to that in a second. Review set 10C number 5. Let me see if I can find that somewhere. Uh, 10C. Scrolling. I'm gonna guess that 10 is at like 220 or something. Nope. Oh wow, I was not even close. 10C. And number 5. Oh, yeah. Okay. So 10C number 5, Coco, I'm happy to talk about. Oh, except my computer doesn't want me to. It's preventing me from screenshotting it. I really don't know why that doesn't work consistently. But just for the record, 10C number 5 was a question that I assigned when we were still learning about trig. I don't like to give questions with the tables of values for trig, though. All right, let's do the ball bouncing one. All right. A ball bounces from a height of 3 meters and returns to 80% of its previous height on each bounce. Find the total distance traveled by the ball until it stops bouncing. All right. Let's take a look. So, the idea is it starts way up here and it falls 3 meters. And then it's going to bounce. And it bounces up to 80% of its original height. So, what is 80% of 3 meters? Or how do you do that? Hopefully everyone remembers. To find 80% of something, you're just going to do 0.8 times that something. So 0.8 times 3 gives you 2.4. So it bounces up, not to the original 3 meters. You know, there's gravity and everything holding it down, making sure it doesn't bounce as high. Wasted energy and whatnot. It's not really a physics question, but it could be. So it goes up 2.4 meters, and then it's going to fall 2.4 meters again. And then next, it's going to bounce up to 80% of that amount. So 80% of 2.4. So if I do 0.8 times 2.4, I get 1.92. So that's how high it goes on the next bounce. And then it has to fall that distance on the next bounce in order to hit the ground again. Because what goes up must come down. And then it's going to bounce up again, and it's going to bounce up 80% of that, and so on. And what's important to realize then is we've got kind of two directions of the ball's movement. We have this downward direction. Whoops, I thought this was going to be bigger. We've got the downward falls, and we have the upward bounces. So it falls down a certain distance, and then it bounces up a distance, and that keeps repeating. So if I was to separate this out into two sections, I'll look at the downward motion of the ball. And so the distances it travels downward are 3 meters and then 2.4 meters. I guess I don't need units there. Let's get rid of that. Then 2.4, then 1.92, and so on. And upward, it is 2.4 meters up plus 1.92 plus on and on and on. Both of these are infinite geometric series. They're infinite geometric series. This is a process that goes on indefinitely. So there's nothing, I guess, in the wording of this. It does say until it stops bouncing, which kind of implies that it's going to keep on going again and again and again. However, there's nothing that necessarily says that it's infinite. You would just assume it goes on indefinitely until the ball isn't bouncing anymore, and then you don't have to worry about it bouncing up or down. Usually there will be some clue in the wording that says this process is carried on indefinitely, or this is carried on infinitely, or this continues until something stops, right? And that implies that it's an infinite series. And so then what we're looking at here is two infinite series with two converging sums. The common ratio for all of them, just for the record, is 0.8 because it's always 80% of what came before. And so if I know my common ratio is 0.8, then for my sum of an infinite geometric series for the downward motions, it's my first term divided by 1 minus my common ratio. For the upward bounces, it's the same thing, except my first term is 2.4. And so the calculations here are fairly easy to do. I have 3 over 0.2, and I have 2.4 over 0.2. So this one is 12, and this one is 15. And so combined, for the total distance, I have 15 plus 12, which is 27 meters. And that's how I would figure out the total distance until the ball stops bouncing. Yeah, and so did we get a request for a bearings one? Oh, maybe Michael found one. Okay, I'm gonna do Coco's question really quickly, and then we'll get on to the one from 9D. Yeah, Ian commented that he thinks he just found One Direction because he said his answer wasn't matching. And yeah, it looks like if you get 15 as an answer, you're only accounting for the downward motion of the ball, and so it's the upward motion, which is basically it would be the exact same distance except for that initial 3 that it fell, right? So you could have just done the calculation for the downward, said, "Oh, it's 15." Double that for 30, except that it didn't bounce up at any point 3 meters, so then you just take away the 3. There's a few different ways of kind of reasoning that out. I said, why are you only using the first numbers? So for an infinite sum, it looks like this. It's the first term divided by 1 minus the common ratio. And so because it is an infinite geometric series, that's how I would calculate it. If it was a finite geometric series, so if it said, Haya drops a bouncy ball, it bounces 5 times, and then she catches it again, then that's finite. It only bounces those 5 times, so you would use the equation for a finite geometric series in that instance. But because this one is implied to keep bouncing until it stops, like the bounces just get infinitely small, we can treat it as an infinite. If you were to do a finite, I'm sure after a few bounces it starts to get close to the infinite one anyway. So I wouldn't be too worried about that being inaccurate. Yeah, anyway, if there are no other questions, I don't know why people are saying press X to doubt. I feel like that's a dig at Ian, but that's exactly what he did. Anyway, so I'm going to move on to Coco's question, which was from chapter 10. And it's the table below gives the mean monthly max temperature for Perth Airport in Western Australia. A sine function of the form t is equal to a sine b, t minus c plus d is used to model the data. Find good estimates of a, b, c, and d. So, to do this, you basically want to figure out the max value and the min value and go from there. So looking at this table, the smallest temperature that we get is here in July at 17.7. The biggest one is here in February at 31.8. Remember, Australia being in the southern hemisphere would have seasonal temperatures that are flipped from us. So we have 31.8 as the max, and then minus 17.7 is the min. And so if I do that, I guess I should write that down. 31.8 minus 17.7, I get 14.1. Now that's the distance between maximums and minimums. And so if I divide that by 2, that's going to be my amplitude. So I get 7.05. I can do the same thing for the baseline, just average them out. 31.8 plus 17.7 divided by 2, that's going to give me D. So 31.8 plus 17.7 divided by 2. I might as well just divide it by 2 in the first step. So 31.8 plus 17.7 divided by 2, 24.75. And so that would be my value for D. The B value is going to be basically found because I know the period is 12, right? In a calendar year, there are 12 months. And so if 12 has to be equal to 2 pi over b, then b is equal to pi over 6 when I simplify that out. And And finally, for C, this is the trickiest one. I said before when we did the other trig modeling one, finding the C value is always the trickiest because you're looking for the starting point of the traditional sine or cosine cycle. And so if I were to visualize this one, it appears that, we've got the 12 months of the year here. Here's just a kind of a crude scale. January, February, and so on. And my maximum is here at February. And my minimum is here at July. And so I've got a graph that looks something like this, right? Now, it's a sine curve, so sine is supposed to start on the baseline right before it heads to a maximum. Now, the problem is, in January, I don't get back to a baseline. Not right away. The baseline actually happens some point before that. And so what I need to do is look along the table and find which months would include the baseline. And so here, between October and November, it looks like my temperature jumps by that baseline value of 24.75. Before that, it's 22.4. After it, it's 25.5. So that means I'm crossing the baseline somewhere between the 10th month and the 11th month. And so I'm pretty sure that what they came up with in the back of the book was they just said, let's split the difference and say if it's between month 10 and month 11, then C is 10.5. If you technically put all of this into your calculator and did a trigonometric regression of some sort with it, like did a curve of best fit, you would probably get a C value that's a little bit different than 10.5, but we're going to say that's sufficient for our liking. The important lessons from a question like this are just how to take the information that's given to find those parameters. I could have just as easily given you this information as a set of points on a graph. Like I could have, my little sketch here that I have between my A and C values that I drew, I could have given you a graph of that and said, okay, here's a trig graph. Here's the maximum point. Here's the minimum point. Here's a baseline point, whatever. I just give you some information. And then you could plug away at it and work to the point where you figure out A, B, C, and D. That is, there's so many different variations on that type of question. And so making sure that you just recognize that if you've got a maximum and minimum, you're pretty much set for A and D. And if you know the period of the function, then you can find B very easily, and then you just have to play around with it to find C. It does tend to be pretty straightforward. Even if I don't give you a full cycle, so this table includes 12 months, which is a full cycle. It's a full period of this trig function. I could have given you like half the year's data, technically, and you still would have been able to do it. You know that even though it's only half a year's worth of temperatures, that we're talking about a full year, so the period is still 12, right? And from that, you can solve for B. That could be true in all sorts of instances. I could give you the distance between 2 points on a baseline, even if it's not a full cycle, sort of the 2 baseline points on either side of a maximum. So what I'm saying is I could give you this one and this one. And because you know that's half the period, you just have to double that distance to get the full period. I think we did one like that in class during review. And so as long as you know how to do that kind of stuff, then you should be just fine. Let's see. So Michael requested one from a review set, and somebody else just requested one. Jack requested one from a past paper. Paper 1, question 8. Did I not do that already? Oh, no, I didn't. That's the sequences in series 1. Yeah, I do like that one. Why do I feel like we've done this one, though? I think my memory is just askew because I posted solutions for the old papers, but I didn't have them digitally, so I had to remake them. And I think that's why everything here is seeming really familiar to me. I remade them on the bus on the way to owl rafting or something, and so yeah, all of it seems familiar to me now. So we'll look at that one, and we will look at the one Michael requested, which I'm hoping is a bearings question. Page 226. 226, number 5. Oh, yes, it is. Very good bearings question, too. Love the names in these questions. I have never taught a student with either of these names. I eagerly look forward to teaching a Ritva and an Esko. Okay. Okay, let's do the sequences in series 1 first, and then I know everyone's very eager to do a bearings question, so we'll do that one next. I don't want to leave anyone high and dry on that one. So number 8, express root 7 as a power of 3. So some people probably look at that and they're like, oh, that's a real freebie question. 27 can be rewritten as 3 cubed, and so because it's the square root of that, that becomes 3 to the 3 over 2. That isn't in there to be a freebie question. It is actually there, though, to help guide you in the right direction for this problem. Because then, before part B, I say a number sequence is defined by the following. Ln of root 3, ln of 3, ln of root 27. And then I say show that the sequence is arithmetic. And that is usually the part where a question like this, which I have done with exponentials and I have done with trig as well, it's a question like this that throws people for a real loop because they're like, wait a minute, whoa, there's logarithms in here. How can it be arithmetic? And the reality is, if you use your log laws here, ln of root 3 is ln of 3 to the 1/2. Then I have ln 3. And then, based on what we just did in part A, I have ln of 3 to the 3 over 2, and so on. If I bring those exponents down, then I have half ln 3, ln 3, 3 over 2 ln 3, or 1.5 ln 3, and then 2 ln 3, if I was to continue the pattern, and so on. And so what's actually happening here is each time I go through a term, I'm adding half ln 3. Right? In the first term I have half, the next term I have 1, then I have 1.5, then I have 2, and so on. So my common difference is actually 1/2 ln 3. And so that's how you would basically be showing that it's arithmetic. I would do the difference between consecutive terms, and it's always the same, right? 3 over 2 ln 3 minus ln 3 is 3 over 2 ln 3 minus 2 over 2 ln 3, so 1/2 ln 3. Right there, that's enough to prove that it's arithmetic. Some people might try and do more. I would strongly caution against that. There are no bonus points for really, really showing that it's arithmetic. You've just got to show that it's arithmetic. And then it says, hence, find the sum of the first 21 terms, expressing your answer in the form a ln b. So the sum of the first n terms of an arithmetic sequence is, that was really bad, n is n over 2 times 2u1 plus n minus 1 times d. Now you do not have to memorize this. This is provided to you, as many of your formulas are. I know there are some of you who have been particularly stubborn about using your formula booklet. Hopefully that changed over the past week as you've been studying. But if you haven't been using your formula booklet, please start using it now. You got to get used to it, because you're going to have it for everything, and you might as well just be really comfortable using the stuff that's on there. So we are basically going to recognize that we're doing the sum of the first 21 terms, so n is 21. Our first term is half ln 3, and our common difference is also half ln 3, which is very convenient. So the sum of the first 21 terms is going to be 21 over 2 times 2 times 1/2 ln 3 plus, and then 21 minus 1 is 20 times 1/2 ln 3. And so 21 over 2 we are going to leave as is for now. But 2 times a half ln 3 is just ln 3, and 20 times a half ln 3 becomes 10 ln 3. And if I simplify that, I get 21 over 2 times 11 ln 3. And so then we just have to tidy that up a little bit, right? 21 times 11 is 231. So I get 231 over 2 ln 3. Yeah. And so that is actually the answer because it says express your answer in the form a ln b, where a is a rational number, which it is. 231 over 2 is a rational number. And then ln b, so where b is a natural number, and yes it is. B is 3 in this instance. So I know that my answer is 231 over 2 ln 3. So that's my final answer for that one. I will say this. A number of people have always read these questions and assumed that when I say that the answer must look a certain way. So here I said the answer had to be expressed in the form a ln b, right? Where a is rational and b is natural. Some people think that that means that you have to write down what a and b are. They think they're solving for it, and then I had some people for sure last year who made this question harder than it needed to be because of that. That misunderstanding, I guess. And so it's really just important you guys understand I'm trying to tell you how to express the answer, not that you have to solve for something. Okay, so I don't know if there are any questions like that on this year's exam. I have it kind of open on the other screen, but I'm not just going to sit here and read through it. It's been a little while since I made it. I honestly don't have a vivid recollection of what it is that we're doing, or what it is that's on the exam tomorrow, I mean. I know generally, but I couldn't tell you the nitty-gritty specifics of each question. Having said that, I do know the bearings are important, so let's look at these bearings. Lovely to see all the mature commentary going on in the sidebar there. All right, so we've got hikers, Ritva and Esko leave point P at the same time. Ritva walks 4 kilometers on a bearing of 40 degrees, and then a further 6 kilometers on a bearing of 155 degrees. Esko hikes directly from P to the campsite. How far does Esko hike? So the idea is Ritva goes this way, the purple path. Esko, on the other hand, goes straight from here to... Oh, that missed. That missed horribly. Esko is not good at walking, apparently. There we go. Esko goes right there along the purple line. And so with the information that's given here, then, I just need to kind of play around with the angles and see if I can solve for the various things they've asked me here. How far does Esko hike is the first one, so I'm looking for this right now. In order to do that, I need an angle within the triangle, which I don't currently have. Remember, in all of these bearings questions, if you don't start with an angle in the triangle, what it means is that usually you can solve for an angle in the triangle based on what's given. So this bearing here is 40. What that means is because this north line and this north line are parallel to each other, that this one has to be 140 here, right? They have to be what we would call co-interior angles, which means that they're supplementary. They're 2 angles contained between parallel lines, so they must be supplementary to each other, so that's how I know that that one is 140. It's the only way they add up to 180. And so now the key is I know 2 of the 3 parts of this angle here, right? It's 360 degrees all the way around. I know that one chunk is 155. The other part is 140. And so I'm going to subtract those from this. And I get that this angle here within the triangle is 65 degrees. And so that's exactly what I needed, because now for cosine law, I can say that a squared is equal to 4 squared plus 6 squared minus 2 times 4 times 6 times cosine of 65. And we'll do it that way. So 4 squared plus 6 squared minus 2 times 4 times 6. You happen to do what I just did, where I typed something in and then realized I was in the wrong angle. The great thing is on your TIs is once you've typed something in, you can just press up on the calculator screen and it'll let you re-access it, and it'll type it in for you just by clicking enter on it. So I get that when I solve for A, it is 5.63 kilometers, approximately. So, common thing in bearings questions, you're being asked to find a missing distance. Usually a good follow-up is something related to a new bearing. So in what direction does ESCO hike? So I'm looking for a bearing specifically from north right around to here, the line to that campsite. Now I already know 40 degrees is part of it, so I guess I know my answer is bigger than 40 degrees, but I need to solve for this angle here, and then that's going to help me figure out the overall bearing. So we'll say the bearing beta is equal to 40 plus phi. And so to find that missing angle, I just need to use sine law. So sine of phi is over 6 is equal to sine of 65 over 5.63. And so when I solve for that angle using sine law, 6 sine 65 divided by 5.63. And then I need to do sine inverse of that amount. And I get 74.98759.236. I'm just going to go ahead and call that 75. So 40 plus 75 then gives me my final answer here of 115 degrees. That's the bearing that ESCO has to hike along. Part C starts to introduce some stuff with rates. So Ritva hikes at 10 kilometers per hour. ESCO hikes at 6 kilometers per hour. Who will arrive at the campsite first? So this requires that you just know the basic relationship between velocity, distance, and time. So we know the distances that each of them travel. So if we look at Ritva, she travels a total distance of 10 kilometers because she goes the 4 kilometer section and then the 6 kilometer section. So her total distance is 10. And we're told that her speed is 10 kilometers per hour. So right away, I have a pretty clear sense of how long it took her. It likely took her 1 hour to walk. Esco, on the other hand, the distance he travels is 5.63 kilometers, but the speed or velocity at which he travels is 6 kilometers per hour. And so I'm just going to do the distance divided by the speed and figure out how much time that takes. So it looks like it's the incredibly awkward 0.94 hours that it takes. So Ritva apparently is getting there first. Esco has a shorter distance to go, but Esco's also walking a fair bit slower. Then when it says how long will this person need to wait before the other person arrives? Oh, wait, did I just mix up which names I said there? Yeah, Esco makes it in a little bit less than an hour. Ritva takes an hour. I think I accidentally said that the other way. Apparently I haven't fully rested my brain from the year-end trip. So Esco gets there in like 56 minutes. So he gets there 4 minutes quicker than Ritva does. So this is approximately 56 minutes. So Esco arrives first. Esco first. And he has to waits 4 minutes for the other person to arrive. And the last question is, on what bearing do the hikers walk from the campsite to return to P? And this one actually, do I even need trig for this? I don't think I do. I think there's a really cheeky way to pull this off. So let's look at the diagram again for a second. I'm actually just going to screenshot this diagram down lower on the page because I just want to add more to it. So we're going to pop this in here. It is not letting me move it. Come on. There we go. All right. And so here's the north line from the campsite. So that's due north from the campsite right there. And when I'm asked for the bearing to go from the campsite back to P, I'm looking for this bearing all the way around from north right around to that pink line. Now, that might seem challenging to find, but let's extend this line here and this line here for a second, these parallel north-south lines that I have. We've already figured out that this bearing up here that I've indicated with a rainbow was 115 degrees. And this angle here must be supplementary with it, so that one's 75 degrees, and it means that this one is also 115 degrees. And there's a few ways you can justify it. Basically, this line here, I really want a different color. This line, nothing is standing out. We'll change rainbow to Angelie's favorite, the blood of our enemies color. So this line right here is parallel with this one right here. And so the idea is that this angle, the rainbow angle, is the same as this one. That's the Z pattern. And so we know that that angle is 115 degrees down here at the campsite, but more importantly, because this is a full line here, this is 180 degrees. So the bearing in question, let's call it, I don't know, D. The bearing is going to be 180 degrees plus that missing angle, which is 115. So we get 295. And that would be the bearing to return. And so that type of question is exactly the kind of thing that you would expect on the exam. In general, the trig questions that I'll do will be one of two setups. It'll be a sideways view with angles of elevation and all that stuff, like question 4 in the section that Michael pulled this question from. Or it'll be a top-down view with bearings. Those are the kinds of application questions that we like to do typically. And so I've already, I think, heavily hinted at the presence of a bearings question. So make sure that you practice your bearings, I guess, would be my best advice to you. I'm pretty sure that there are other bearings questions in the review sets and in those textbook exercises. Number 15 we did with Sam and Marcus in the tree. That was a really tough one because it went into 3D. I'm not going in that direction on the exam. And Donald's saying, what about for the other person? So Donald, in the context of this question, both of them end up at the campsite together. So Esko and Ritva meet up at the campsite, and then they want to go back to point P. I don't know why. Maybe in the context of the question, P is where they parked their car, and Ritva walked one way to the campsite, and Esko walked the other way, and now they're just going back to their car at the end of the camping trip. I don't know what the rationale is. This is not a question that I made, but that would be my assumption. And so as far as the other person, they're walking on the same bearing back to the point P. To Haya's question, will bearings be a large portion of the exam? No. I would argue that there is no topic really that's a large portion of the exam. if you recall, we talked about in the review class, just there's so much stuff in terms of volume that it would really not be possible to spend too much time on any one thing. So there is sort of one problem on optimization. There is one trig question with bearings. There is one, I don't know, sector area and arc length. I'm looking over at the textbook and seeing what's visible right now, and I'm just kind of going from there. There will be one thing with infinite sequences in series, one with geometric, one with a binomial expansion. You're not going to see things show up multiple times. You're not going to get dinged repeatedly for the same concept. It's always going to be um, evenly spread out. There were some bigger topics that I didn't get to fit even onto the exam in an organic way. Um, Either the question is very simplistic or there are certain topics that didn't actually make the cut. Um, like I tried very committedly to get like a solid discriminants type question on there, and I just couldn't get it to fit in with the mix of everything else that I wanted to do. So there's actually not a huge discriminant presence on this exam. Um, Trig though is still present. I think I gave the breakdown of the marks in one of the classes, or maybe I had intended to, and then people started asking me questions. I'm just going to pull that up right now. So let me see. Courses, FSL, summatives. And let me just pull up the whole exam here on the stream. Not sure what Michael is woohooing to. Because of the delay, or I assume there's still a delay, I suspect that woohoo was directed at the absence of the discriminant stuff, but I don't actually know. Maybe there is very little delay this time. Okay, I'm not screenshotting that one for you, or that one. Here we go, my gold standard page. So whenever I create your exam, I don't do this for tests because with tests, it's all on one topic typically, so I don't look at the balance in the same way. But when I create an exam for you, I look at the topics that I want to make sure that you're prepared for, and I want to make sure that they are balanced appropriately. Jack, I was saying the discriminant does not have a huge presence, so I wouldn't put your efforts into focusing on the discriminant in the final hours you have of studying tonight. Discriminant in general would be used if there was a missing parameter, and I told you that something had 0, 1, or 2 solutions, or it implied it in some way. I wouldn't worry too much about that. So if you look at the gold standard here that I posted, the gold standard is the number of marks that, based on the fact that this is out of 120 marks, it's roughly how many marks should be allocated to each topic. So there should be roughly 15 for topic 1, which is like your sequences in series, log laws, binomial expansions. Topic 2 is your functions. 3 is trig, and topic 5 is stats and probability. So stats and probability I kind of hit right on the nose. Based on the balance of the exam, there should be about 39 marks devoted towards that topic, and there are. According to the gold standard in keeping it balanced, there should be about 39 devoted to functions. Now, I skew a little bit less than that because on the final IB exams, the way they're able to actually accomplish that is by tying those functions questions in with calculus. You guys don't know calculus, so it's harder to give you the same range of questions that deal with that topic. So it's a little bit less. That's your logs, your exponentials, all that stuff is a little bit more downplayed, but trig covers the balance a little bit, and so does sequences and series and binomial expansions. I gave an extra 5 marks towards those topics. I know that was an area of strength for a lot of people, so I'm hoping that that will be helpful. And trig people tended to do very well there, so we're going to kind of see that that works out well. Or at least I'm keeping my fingers crossed that it does. Yeah. And so that's basically the main breakdown of stuff on the exam. Despite Haya and Michael's reactions to sharing the whole exam, I'm obviously not going to do that. That would be ridiculous, but I could conceivably share the title page, because I know at some point somebody's going to ask me, wait, how many marks are there towards certain things? So here's the title page of paper 1. It does not indicate topics, but it does give you a sense of what kinds of things are showing up in terms of thinking, application, communication, etc. And then here is the title page. I'm just trying to make sure I screenshot it consistently. Here's the title page of paper 2. So there are 8 questions on each. Where did that title page go? The second one didn't pop in. There we go. There are 8 questions on each one. Really important to remember that, yes, there are 2. I think the proctors will hopefully encourage a switch between paper 1 and paper 2. Those are the instructions I've passed along. Again, I won't be in the exam hall. So you should spend exactly an hour writing the first one and then exactly an hour writing the second one. So it's almost like you're writing 2 tests back to back. One is just without a calculator and one is with a calculator. It's important that you distinguish which ones are which. I write paper 1 and paper 2 in capitals there at the top so that after your reading time, you make sure you put the right one down on the floor with your calculator. I did, and you might think that's a ridiculous thing, but I did have one year where a student legitimately, the exam started, they had the reading time, they read both, and then when they went to put one on the floor, they put down the paper 1 by accident, and they sat there for about half an hour doing paper 2 without a calculator, not realizing. And they were like thinking to themselves, gosh, this is really tough. Like, how am I supposed to do trig without a calculator? And then they realized, and then they asked the proctor if they could switch, but there was no way to make up that time. So you do have to make sure that you're very careful about which one is which. I don't know if you want to, when you put your name on the front, put like in big Roman numerals beside your name so that you don't accidentally goof up, or you can just make sure you read carefully. Paper 2 is the one that is 10 pages long, and paper 1 is 9 pages long, and hopefully you'll be able to differentiate between the two. Yeah. So that's a breakdown of the papers, and we're just about at the end of our time. According to my watch, it's about 2:58. And yeah, we've been at this for an hour and 58 minutes, and I don't know how many of you have been here the whole time. For some reason, the statistic for people watching now has been fluctuating wildly this whole time, and I don't know if you guys are having trouble staying connected or what's going on here. But I hope everyone was able to get what they needed out of this, or at least feel more confident going into the exam tomorrow that you guys have sorted yourselves well and are well prepared. I had a lot of people asking me questions from the exam from last year, which I hope means people are feeling confident and roughly at the end of their studying time, as I asked you to save that paper for your final bit of review. I'm glad to see that some people have done that. I did post all the old tests too, so you have those at your disposal if you need to go back and look at old questions. Yeah, it really practices the order of the day, and at this point you want to make sure that you're firming up as best you can the topics that you're not feeling comfortable with, so that tomorrow you can go in. Remember, use your reading time. And I'm giving you all these reminders now because I won't be there to give them to you in person tomorrow. Use your reading time to go through, prioritize the questions that you're going to do, and the order that you're going to do them in. There's no rule that says you have to solve the exam from question 1 to question 8. You should be playing to your strengths. And so if you look at question 1, and question 1 is something where you're like, oh man, I'm not feeling super confident with, I don't know, probability or whatever. And if that's the case, then, move on to the next one. No one says you have to start there. That's the whole point of the reading time. You should be using it in a very tactical way to make sure that you're getting the most out of the exam. Yeah. What else did I want to remind people of? Yeah, make sure you know how to reset your calculator. If you have a TI 80 series calculator, please make sure you remember to turn diagnostics back on before you do any stats questions on paper 2. I don't want you to do a linear regression and looking for an R value and then you have it shut off so you don't get an R value. That would really be unfortunate. Did I post the mark schemes for the test? Oh, yes. So the past tests, Noor sent me an email asking about that. And I did go and post solutions. I couldn't find them for the longest time, and then I figured out what folder I'd kept them in. And I haven't been very consistent about my filing this year, apparently. And so I found them, and they are up. If you go into the OneNote, which actually I'm in, so I guess I can show you. To find where the test solutions are, we would go to Old Assessments. And then, underneath each of these now, I have put a tab with the solutions. I don't know why that's zoomed in so far. There would be your first test is on this tab. And then the solutions to that first test are immediately below it. And it's just the scanned copy of the solutions that I made when I went through and marked. And I think this is the right one, right? I didn't upload the wrong thing. Algebraic skills and quadratics. Yeah, it looks like it's correct. Either that or I just happened to weight everything exactly the same. Yep. So they're all up there. I could not find solutions for the midterm for some reason. I do not know why. I will keep looking, but I don't know if I'll have time to actually post solutions of that tonight if I can't find them. I wouldn't have the ability to create new ones. So if you're studying from our MCR3U exam, I know I had solutions somewhere. I could have sworn I posted them already. But if you are practicing from that one, just make sure you compare with somebody else because I don't know that I'll be able to redo solutions tonight to get those posted with everything else that I've got to get sorted after the trip. Being away for, a full week and on for 24 hours of the day, it makes it kind of hard to finish all the other work that you have on the go. Jack, to answer your question, what is the final worth? The final is worth what the final is always worth, which is 30% of your grade. So all of your term work will be worth 70%. So that will be your 3 unit tests on trig, which were the first 2, and then stats, which is your third one. I will use that. I will also be looking back at your midterm exam and your previous test just in case that, gives me a good sense of your understanding and how it has changed going into this exam. But really it's going to be mainly those 3 tests. And then if I see improvement on the exam, then that gives me the flexibility to adjust your mark accordingly because it shows that you actually have learned over time. And so if you did really poorly on the second trig test because you struggled with trig identities and equations, but then you rock that question on the exam, then you've shown me that you have actually learned from your mistakes, which is the ultimate goal here, right? I'm not trying to peg you to what you were able to do back then. It's about what you're able to do now. I don't know why, Jack, you're asking what the midterm was worth. That feels like kind of an irrelevant question right now because the midterm was worth 30% of your grade for your MCR3U, your grade 11 credit, but all that stuff got locked down back in February. So your February report card already had that mark on it. So we're past the 3 o'clock mark now, which is when I said this was going to uh, wrap up. Um, and so if there are any other questions at this point in time, I can't answer them, but I am also reasonably sure that Matilda is up from her nap. So this nap window of productivity that I have has kind of run its course. So, any final questions? All right. Then I guess we're going to wrap up the stream here. So thanks everybody for showing up. I'm glad I was able to connect with you guys for a little bit of time today to consolidate some review from the time that we missed over last week. So I hope all your exams have been going well so far, and I hope that the math exam tomorrow is going to be like the cherry on top of a wonderful exam session. Hope everything goes well. Hope everyone's feeling positive. If you have any sort of last minute concerns before you go in right after lunch, just feel free to come and find me. I'm happy to help troubleshoot calculator stuff. Just remember, I don't have spare batteries, I don't have spare calculators, so you need to make sure you bring what you need. Get your little clear plastic bag out or whatever they've trained you guys to come in with, and come in with all your supplies. And then keep a clear and level head. Don't let yourself get too panicked when you see tough questions. Trust what you know, and I'm sure you guys are all going to do great tomorrow. So I'm going to stop streaming now, and I hope you guys have a productive day of studying with the time that you have left. And then, like I said, good luck tomorrow. I hope everything goes well.